Hi everyone, and welcome to lesson 28.2. Today we are going to talk all about converting rectangular coordinates to polar coordinates and vice versa. So we're going from x comma y to r comma thetas, and then we'll also go the reverse way when we're talking polar to rectangular. So we're going to jump ahead to page 382 to start today. So when we want to convert from polar to rectangular, what we're going to see is that we're going to use our knowledge of right triangle trig to convert. So what we'll see is if we're at x comma y, that's kind of leading us to that r comma theta point. So when we are looking for the x and the y, then in order to find x, we're taking our theta value. We have the hypotenuse is 40 here. So you would be using cosine of your adjacent over the hypotenuse to solve for either the exact answer or the approximation. And same thing then to find your y value, you're going to need to use sine, opposite over hypotenuse, and then solve, look for the exact value or the approximation. So big thing here is converting polars to rectangulars. The x value is found by taking your radius times your cosine value. The y value is found by taking the radius times your sine value, your r value times sine. Okay, so if we look at a couple of these to practice, okay, for part A, we have a triangle, and we didn't talk about this in the beginning, but there was this location, an r value of being at 20 comma 60 degrees. Okay, so if we were to convert this, again, think about right triangle trig, 60 degrees, radius of 20, x comma y, where would we be at? Well, the x value would be at 20 times the cosine of 60, because it would be setting it equal, to opposite over hypotenuse. So multiply, solve, and then 20 times the cosine of 60 is going to be 10. And again, you're going to want to make sure that your calculator is in degrees mode. And again, 20 cos 60. And then for the sine, we get 20 sine 60. You get about 17.3. Or 10 square root 3 if we were using exact values from the unit circle. But for the most part, we can just approximate on this. Okay, 17.3. Now, if I told you instead, if we go down to part C, we kind of skipped over this again. But let's say I wanted you to convert 40 comma to 10. It would be that same process. X is going to be 40 cosine 210. Y is going to be 40 times the sine of 210. And if we type these in, 40 cos 210, 40 sine 210, we see these values here. Now we have to consider the fact that it probably looks at first, you're probably like, why is my answer negative 34.6 versus a positive value? But think about if you're at 210 degrees, you would be in quadrant 3. Oops, sorry. Negative 20, you'd be in quadrant 3. So it makes sense that our two values were negative because we went to the right and down for that quadrant 3 value, even on the polar grid. Okay, so again, the negatives will just tell you, again, what quadrant you're in versus the polars. Now, we also can convert then the opposite direction as well from there. So I have some examples for you to practice here. And then we want to talk about converting the other direction as well. So on page 384, when we talk about converting this other direction, we want to talk about thinking about, again, if we knew the rectangular coordinates, so in this case, we're at 3, negative square root 3, we would be down here. And what if we wanted to figure out the theta and the r for the going from these rectangular now to polars? Well, to get the r value, aka the hypotenuse, we would have to take 3 squared plus negative 3 square root 3 squared, and we'd end up finding the square root of that, because think Pythagorean theorem, right? C squared equals a squared plus b squared, and then we'd end up having to square root, okay? So we end up getting an r value here, be careful of how you're typing this in, of 3 squared, and then plus 3 to get our answer there of 6, okay? So we have the r value is 6, and then to get theta, we have opposite and adjacent given. We would be using tangent to help us figure out, okay, opposite over adjacent. So really we're looking for tan inverse of the 3's cancel. So negative square root 3, well, tan inverse of that, negative square root 3, we would have negative 60, which does work as an answer. We could have 6 comma negative 60, but we also know officially, with quadrant 4, that there's multiple ways we can write this, okay? Because officially we could call this 6 comma 300 degrees if we needed this to be between 0 and 360. And then even beyond that, there's officially more ways we could even write this. For instance, we could talk about this being negative. Remember, we talked in the last lesson about adding or subtracting 180. So this would now be at 120. We see a bunch of different options we could have here. We could also do negative 6. We could subtract from the 60, the 180. We'd be at negative 240. So officially, like, all of these answers are talking about that same rectangular location that only had one option, okay? So same idea for practicing one more of those. This time we would be if we're in quadrant 3, right? We're at negative 2 square root 3, negative 2. Here's our theta value there. Okay, so for r, again, think Pythagorean theorem. We need a squared plus b squared, but we're going to end up square rooting to get just the r value, right? Not r squared. So as you type this in, again, be very careful with your use of parentheses. We would have negative 2 square root of 3 whole thing squared plus parentheses negative 2 squared for an answer of 4. And then again, opposite over adjacent, to get our theta value, we're again using tan inverse opposite over adjacent. So really 1 over the square root of 3. The negatives cancel out. Since it's negative over a negative, we get 30 degrees. Okay, now on this one, you have to be careful because this is not 30 degrees. This is not quadrant 1. Really what we need to consider is that this is in quadrant 3. So we would have to call this either 30 degrees past 180, which is 210, or you could have called it negative 150 degrees. Because of the location this way, but you definitely don't want to say 30. That's actually not the correct answer. So you would want to write 4, 210, or 4, negative 150. Okay, 30 degrees would not be appropriate here because of that location. Okay, now your calculator can help you find the polars to rectangulars. Okay, and actually we can go the opposite way as well. But if you look on your calculator, and this is actually on the next page here as well, excuse me, on page 385, it's telling you how you can use your calculator to help you find from polar to your x coordinate, from polar to your y coordinate, looking here. So if we go under the second and then the angle menu, so second apps, you'll see these down here. So what you can do is if you're looking to go from x to y, you would take 7, and then when you type this in, you're going to type it in as your r comma theta. So we have, for the examples down here, let's say we're looking at part C, 3.5 comma 29 degrees. This is telling you your x value. And then you would do the same thing, second apps, and you would scroll down to option 8. And you would type in that same value, r comma theta, and now you have your y value. Okay, so this is going from polar to rectangular. Now, to me, I personally think it's quicker to just do r times the cosine of theta and r times the sine of theta. Because to me that's quicker to type in than having to go through all those menus. Oops. But you see you get the same answers for your x comma y's. Now we can do the same thing for our values as well when it comes to looking at going from the other direction, from rectangular to polar. You'll see in the same menu from the second apps, you'll see that for polars and rectangulars. Again, it's 2 steps, so you would do 5. But let's say we're going back to this problem we were talking about in number 6, where we were at -2 square root 3 comma -2. We have the r value. And if we do second apps and then option 6 this time to find the theta value, this one to me is especially helpful. So we have -2 square root 3 comma -2. It takes into consideration for us, which is really nice, the fact that this was in quadrant 3. So we see that -150. Okay, so these are great resources to be able to check your answers on here as well. Okay, but again, we'll focus more on this in upcoming lessons as well. All right, thanks everyone for watching, and we will work more in class.